Hi, and welcome to Luke Rich's Chemistry Culminating SNC2D. Let's get started. We are given a chemical equation and you're put into a word. So, aluminum plus copper 2 chloride forms aluminum chloride plus copper. Aluminum and copper 2 chloride are the reactants. Aluminum chloride and copper are the products. Now the chemical equation. Al plus CuCl2 forms AlCl3 plus Cu. Now we're going to have to balance this chemical equation, so first we're going to list all the elements involved. Al, Cu, and Cl. So we have to balance the metals first, which are Al and Cu, then the non-metals, Cl. So there's no number under Al, so let's just list it as 1. And on the other side, on the product side, Al, there's no number under it, so it's a 1. Now for Cu, same thing, no number right beside it. So we're going to put a 1, and on the other side, no number involved. So it's a 1. Now for chloride, you see a little 2 there. So now we're going to list it as a 2, and on the other side, has a little 3. So we're going to list it as Cl3. Now, to do this, we have to look at how to balance the metals first. So Al, you can see they both have 1 on both sides. So we are okay there. And same as with Cu, 1, 1. But now Cl gets tricky here. We have a 2 and a 3. So first step, I'd put a coefficient number in front of this compound here. Let's put a 3. So that creates a 3 going to copper and a 3 going to Cl. But Cl already has a 2 there, so you do 2 multiply 3, which creates 6. And for Cu, just 3. 1 times 3. And now we see that they're all mixed up now. Now let's do it on the other side. So let's put a 2 here. That creates the 2 times 3 for Cl and this 2 to Al. So Cl will have 2 now. And Al will have 2. Or sorry, this is supposed to be 6. So now we got the chlorides equal. So we kind of did this backwards. We were supposed to do the metals first. But now aluminum's got 2 on one side and 1 on the other. So now we have to put a 2 here. 2 times 1 equals 2. So this is equal now. Aluminum, both 2's. And now copper, we got 3 and a 1. So we have to put a 3 here. 3 multiply the 1, which creates 3. Now our metals are equal, 2 and 2. Non-metals, 3 and 3. And chloride, 6 and 6. So the full overall balanced chemical equation is 2Al plus 3CuLCl2 forms 2AlCl3 plus 3Cu. The type of the reaction. This equation represents a single displacement, meaning that a single element, which is Al, replaces another in a compound, CuCl2. As you can see by the arrows there, Al moves over to the Al, forms into the CuCl2 compound, creating AlCl3, and the Cu moves on its own. Relationship between ion charges and chemical formula. As you can see, each element has an ion charge. And to do this, you have to crisscross the elements to drop them down. Their valence charge, you drop both the signs, and you create. So Al3+, that's just left alone for now. But as you can see, you crisscross them down, as copper has a charge of 2. And then chloride has a charge of -1. But -1 is never shown on a compound, so you see there's no number there. But there's a 2 shown, which creates CuCl2. And now Al has a charge of 3, so it drops down to the chloride, and 1 negative does not get shown once again. So AlCl3, and Cu just has copper, has a charge of 1+, so it's not even shown. So our overall chemical formula with the ion charges is Al plus CuCl2 forms AlCl3 plus Cu. Now the next word equation we are dealing with is aluminum chloride plus sodium hydroxide, which are the reactants, forms aluminum hydroxide plus sodium chloride, which are the products. Now the chemical equation. AlCl3 plus NaOH forms Al bracket OH bracket 3 plus NaCl. Now, we're going to balance this equation once again. So remember, let's list all the elements. Al, Na, Cl, H, and O. And remember to balance the metals first, which are Al and Na, then the nonmetals, Cl, and hydrogen and oxygen. So Al, we see there's no charge listed there with a subscript, so it's going to be 1. And same on the other side. And Na looks the same situation as Al, so just 1 and 1. Now Cl, you can see there's a little 3 there. So we're going to put down a 3, and on the other side, there's nothing, so that's a 1. And on H, on this reactant side, there's just nothing, so there's a 1. And on the other side, you see the bracket, and you see the 3 outer it. So the 3 actually enters everything inside the bracket, creating H to have 3, and O on the other side, just 1. But now O on the product side, the 3. As remember, the charge goes into everything inside the brackets, creating O and H to both have 3. Now to balance this, we do the metals first, the non-metals, and then hydrogen and oxygen. As you see, Al and Na, they are both balanced with each other, but chloride is not, so let's start there. And you see on this side, this has 3, so we're going to have to make this side have 3. So we're going to put a 3 in front of this compound, creating Na to have 3 now, and Cl to have 3. So let's change it on our table. Cl3, Na3, and now, so chloride's balanced, but not sodium, so we have to go back. So now on this side, let's put a 3 here, because we need to make Na have 3, because on the product side it has 3. So let's make it here. So now, 3, but remember, it goes to everything. So O goes to, and goes to H as well. So this makes H have 3, and O have 3. Now let's look at our table. We have aluminum's balanced with 1, Na's balanced with 3, chloride's balanced with 3, hydrogen's balanced with 3, and oxygen's balanced with 3. So everything is balanced. So our final balanced chemical equation will be AlCl3 plus a coefficient of 3 NaOH forms AlOH3 plus a coefficient of 3 NaCl. Type of reaction. This equation represents a double displacement, meaning that parts of two compounds switch places. The positive ions and the negative ions of the two reactants switch positions, forming two new compounds. So as you can see in the diagram there with the equation and the arrows, Cl from the aluminum compound forms to the sodium on the product side, creating NaCl, and the compound of sodium hydroxide on the reactant side, the OH goes to the aluminum on the product side, creating aluminum hydroxide. Relationship between ion charges and chemical formula. As you can see, Al has a charge of 3+, and chloride has a charge of -1. So remember, you crisscross them down by dropping the plus and minus sign, creating AlCl3. Because remember, 1 is not written, so Al just leaves a blank, but Cl has the 3. And for Na and OH, Na, which is sodium, has a charge of just +1, and hydroxide, OH, has a charge of -1. So remember, you don't write 1, so it's just Na8OH. And now on this side, aluminum 3 crisscross, dropping the sign, and OH crisscross, dropping the sign, creating AlOH3. And now Na charge +1, and chloride charge of -1. You crisscross them, drop the signs, creating NaCl. Now final chemical equation, AlCl3 plus NaOH forms AlOH3 plus NaCl. Similarities and differences of reaction types. The difference between the two reactions is that the reaction between aluminum chloride plus sodium hydroxide is demonstrating a double displacement reaction, which is when two parts of the compound swap places to form new products or compounds. The reaction between aluminum plus copper-2 chloride, the first one we are demonstrating, is showing a single displacement causing an element to move from one compound and switch into another. But a similarity between these two reactions is that they both form a chloride compound as a product. Law of conservation of mass. The law of conservation of mass states in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. Atoms can only be rearranged, not created or destroyed. That is not part of the law of conservation of mass. That is another part of balancing chemical equations. You can see that we don't destroy or create, we just rearrange. Therefore, in this case, aluminum plus copper-2 chloride, the first equation we dealt with, the total mass has to be equal to the mass of the aluminum chloride plus copper after. And the equation we just dealt with, aluminum chloride plus sodium hydroxide total mass, is equal to the mass of aluminum hydroxide plus sodium chloride. So remember when we drew the coefficients, the numbers had to be balanced. And that relates to the law of conservation of mass, which remember states total mass of reactants is always equal to the total mass of the products. Safety and environmental concerns. For aluminum plus copper 2 chloride forms aluminum chloride plus copper, we are just going to list the environmental concerns for each element. So aluminum. In an aquatic environment, aluminum acts as a toxic product to gill-breathing species such as fish. Safety concerns of aluminum are don't breathe and may be harmful, contact to your eyes may cause irritation, and exposure may cause mental fume fever, which is a flu-like illness. Copper 2 chloride. In the environment, it can be very toxic to aquatic organisms and may cause long-term effects in the aquatic environment. In human cases, it can be toxic if swallowed, irritating to eyes, respiratory system, and skin. Now, aluminum chloride. It reacts violently with water, so it can damage the environment if used wrong with water in ecosystems. May be corrosive to metals, may cause respiratory irritation, may cause damage to organs through prolonged or repeated exposure. Now, copper. Copper does not break down in the environment, and because so, it can accumulate in plants and animals when it is found in soils. Once again, it can irritate the skin, harmful to eyes, and can damage kidney or liver if exposed in industrial setting. How the reaction use. The reaction of aluminum plus copper 2 chloride, the first one we dealt with, creates aluminum chloride and leaves pure copper. Copper is used in industry for building construction, power generation, and transmission, production of industrial machinery, and transportation vehicles. Copper wiring and plumbing is used in appliances and heating and cooling systems. The demand of copper has increased dramatically since the past couple of years. So that equation we dealt with is actually very helpful as it leaves pure copper and is used in industry and even home. Chemical reaction, Chagall. Chagall states the different types of chemical reactions that can occur and how to identify what happened. So the C stands for color change, H, heat produced, G, gas produced, L, light produced, and P, solid precipitated. So during the reaction between aluminum and copper 2 chloride, which we tested, some evidence of a chemical reaction were color change. It turned an orange-brown copper color as it forms pure copper. A gas was produced, and a heat produced. As we took the temperature at the beginning of the reaction, it changed when the aluminum foil was added, and the temperature went up and increased. And that is the end of chemical reactions with Luke Rich. Hope you can join us in a few weeks as we have more chemical reactions to come. Thank you.